Proof that for all n natural number, there is no n such that the following expression is never a perfect square larger than 0. The floor of the quantity of n squared minus 1 all over 4. To solve this problem, we divide this problem into two cases. The first case is where n is an even natural number. The second case is for n is an odd natural number. For the first case, we let n to be equal to 2 times some random 2 times some natural number k. Then we substitute this to the original expression. So the expression will become the floor of 2k squared minus 1 all over 4. This equals to be 4k squared minus 1 over 4. Then we divide every term on the numerator by the denominator 4k over 4 minus a quarter. This becomes k squared minus 1 over 4. Then if we look at the term inside the floor, which is k squared minus 1 over 4, this term is strictly smaller than k squared, but always bigger than k minus 1. That means this term, if we floor it, the result will be k squared minus 1, which is never be a perfect square larger than 0. We will moving on to the second case. N is an odd natural number. For this case, we let n to be equal to 2 times some natural number m plus 1. Then we substitute to the original expression, and becomes 2m plus 1 squared minus 1 all over 4, and then floored. Then we expand this quadratic term to be this result to be 4m plus 4m squared plus 4m plus 1 minus 1, and this cancels to be 0. Thus we have 4m squared plus 4m all over 4 floored, and this result to be m squared plus 4m squared plus m. Because m is already an integer, that means the floor doesn't do anything, so we can erase it. But this term m squared plus m is strictly smaller than m plus 1 squared, which is m squared plus 2m plus 1, but also bigger than m squared. Because this term m squared plus m is between two consecutive squares, that means this term m squared plus m is never a perfect square larger than 0. Thus, we proved that n squared minus 1 over 4 all over 4, then floored, is never a perfect square larger than 0.